So students, we discuss up to the question number 9. So we can move to the next question, number 10. A good concept. Even it is important even for our board examination. 2-point charges plus 8q and minus 2q are located at x is equal to 0 and x is equal to L respectively. The location of a point on the x-axis at which the net field due to these 2-point charges is 0. We can draw a figure at first. So for the question number 10, it is given at x is equal to 0 and say here x is equal to L plus 8q and minus 2q are placed. Along this x-axis we have to find the field where the electric field is 0. And keep in mind, see, roughly suppose we take one point, say P1 here. In order to find the electric field, the first step is to place a test charge at this point. But if we place it, this charge is repelled this one, and hence the force is acting in this way, or the field direction is in that way. But minus 2q will attract it. And hence we can surely say, in between the 2 points, there is no chance to nullify. And suppose we can take another point, say here, the point P2. And suppose from this point, say this is at a separation as x. And from this we can say it is up to this point as L, so hence L plus x. And have to think one point. At this point, the electric field due to both of the charges should equal to 0. That is E1 plus E2 should equal to 0. What is E1? It is simply as a k into the charge, kq by r square, the separation square. So plus 8q, that division by r square. What is the separation here? It is L plus x. So L plus x square plus. And what about the contribution from this one? And hence we can say as a k into this charge is minus 2 cube by, what is this one? The separation x square, it should equal to 0. And hence we can say easily as a k into 8q by L plus x the whole square equal to k into 2q by x square, where kq cancel 2, it become 4. And hence we can say that x by L plus x the whole square, take the value equal to 1 by 4. You take the square root, you get the value as x by L plus x, take the value equal to 1 by 2. You can take crossing, you get the value as 2x is equal to L plus x. That means x is equal to L. But we keep in mind, we have to find the location of the point from x is equal to 0. And hence it is L plus x is the answer. And hence we get the value L plus L is equal to 2L. And this concept is very important. So we get the answer as a C. It's a very important concept to keep in mind. To follow this superposition principle, it is so simple. If you just take the point in between, no doubt at all, you get the answer. But one more answer you get it, then we have to nullify it. So the neglect it, then we get again this answer. We can move to the question number 11, another good concept. Two small spherical shells A and B are given a positive charge of 9 coulomb and 4 coulomb respectively and placed such that their centers are separated by 10 meters. If P is a point in between them where the electric field intensity is 0, then the distance of the point P from the center of A is. We can draw the figure for the question, and here it is given two spherical shells, and we can mark that as A and B. Here it is given as 9 coulomb, here it is given as 4 coulomb. From the centers are separated by a distance of 10 meters. And suppose here is the point where the electric field is 0. Now we can mark it as from A at a separation x. Then from this point we can say it is 10 minus x. In order to the electric field becomes 0, we can roughly say the magnitude at this point EA should equal to EB, or we can say the modulus of EA plus EB should equal to EA plus vector EB should equal to 0. But we need the separation x only. So what is EA? Simply as a K into the charge 9 coulomb division by the separation square should equal to K into, here the charge is 4 coulomb division by the separation as 10 minus x the whole square. So k cancel, and you get the value as 10 minus x by x the whole square is equal to as 4 by 9. You can take the square root, you get the value as 10 minus x is equal to 2 by 3. On crossing, as 30 minus 3x is equal to 2x. So 30 take the value is equal to 5x. That x is equal to 6 meters. That is answer. So this question number 10 and 11, what is the special aspect? We can easily find where the electric field becomes 0 between the two charge contributions. We can move to the next question, number 12. Question number 12. The electric field in a certain region is acting radially outward and is given by capital E is equal to A into R. A charge contained in a sphere of radius A centered at the origin of the field will be given by. So we can say like this one. A charge, a sphere is here, one sphere is here. Here the charge is there. At a separation R, say our aim to find the electric field. But the electric field is variation is like this one, E is equal to A into R. So how we can find? We have to find a charge contained in a sphere of radius A. So we have to find the value for Q. So we can use the concept of electric flux. You know the concept for the electric flux is what? The flux is nothing but equal to the charge enclosed division by epsilon 0. So the charge is what? The flux there into epsilon 0. If we just consider the Gaussian surface got the radius R, The flux is nothing but equal to E into the area. It is nothing but the 4 pi r square into epsilon 0. But we know what is E. E is given as AR into 4 pi r square epsilon 0. But here the R is substituted as A, and hence we can say as equal to A into 4 pi A cube epsilon 0. A simple concept, and hence we can say the answer as C. Number 30. The question, it is that concept is so very important for board exam also. A pendulum bob of mass 30.7 into 10 raised to minus 6 kilogram and carrying a charge of 2 into 10 raised to minus 8 coulomb is at rest in a horizontal uniform electric field of 20,000 volt per meter. The tension in the thread of the pendulum is. So the same concept we dealt in the last few questions, but we can go through again once again. So a horizontal electric field is there. So, and suppose that a pendulum got a positive charge, it should be attracted towards the negative aspects, and hence it takes an angular displacement. You can just think about what are the forces acting on it, the weight mg, the horizontal force q into E, the tension acting on it is as T. At first we can split that tension into two components. If it is theta, then we can say it is a T cos theta, and it can be written as a T sin theta. At equilibrium we can say the T sin theta take the value equal to Q into E, and T cos theta take the value equal to M into G. And if we just divide, we get the value as a tan theta equal to QE by M into G. You can substitute the values is equal to Q as 2 into 10 raised to minus 8 into the electric field as 2 into 10 raised to 4 division by, as mass it is given as 30.7 into 10 raised to minus 6 kilogram into 9.81. We need the value of T. That means we need to find the sin theta, and hence we can change that tan theta of the form sin theta by cos theta. Cos theta can be written as 1 minus sin square theta. By solving this one together, we get the value as 1.329, and if we get the value for sin theta is equal to 0.75. Then you can substitute it for this relation. So tension take the value equal to QE by sin theta, that is equal to 2 into 10 raised to minus 8 into 2 into 10 raised to 4 division by 0.75. So you get the value approximately 5 into 10 raised to minus 4 Newton. So a simple question. So we get the answer as a C. We can move to the next question, number 14. Question number 14. Which of the following is false for electric lines of force? They always transfer positive charge and terminate on negative charges. It is a right concept, you know. They are always perpendicular to the surface of a charged conductor. Already we know that. It is also true. They always form closed loops. That may be the false one. It never but it forms closed loops in some special cases, but in the normal situations it never forms closed loops. It is the answer for the question. We can just go through the choice D. They are parallel and equispaced in a region of uniform electric field. So you know that is also a true concept. So we can give the answer for 14 as C. Number 15. 3-point charges plus Q, minus 2Q and plus Q are placed at point x is equal to 0, y equal to 0, z is equal to 0, 0, 0, 0 and a 0, 0. The magnitude and direction of the electric dipole moment vector of this charge assembly. So at first draw the charge distributions. So this is taken as our concept. Then the first one, take the point as a plus Q is at 0, A, Z is equal to 0. So x is equal to 0, y take the value as A. So say this is the point, we can say as 0, A, 0. So this is the chart here, plus Q. At origin it is minus 2Q, minus 2Q. And when x is equal to A, there the charge is plus Q. You already know what is the concept of dipole moment. You know, for an electric dipole, minus Q plus Q, two equal but opposite charges are separated by a vector distance. That is the concept. So we can divide this minus 2Q into minus Q minus Q. That means this will form a dipole, this will form another dipole. With respect to the origin, we can say this is a dipole, this is a dipole. And hence, surely the vector sum should be like this one, with a value root 2 times of P or root 2 times of charge into the separation as A. So that is the answer. And it must be act like this one. This is the point. So this line, in this plane of x and y, so there x should equal to y. That is the point, because these are equal with the 45 angle. So which choice is favorable? Good. A is the answer. A good concept. Then we can move to the question number 16. Number 16. An electric dipole of moment 400 microcoulomb is placed in a transverse electric field of 50 volt per meter at an angle of 30 degree to the electric field. Then the torque acting on it. Simply, we know the relation. In vector form, the torque twice equal to P cross E. In modulus, we can say it is equal to PE sine theta. So you can substitute for the values. The dipole moment is given as 400 microcoulomb meter. So 10 raised to minus 6. The electric field is 50 volt per meter. The sine 30, take the value as 1 by 2. Solving, you get the value of 10 raised to minus 2. And hence we can say C as the answer. Number 17. Again a simple question. An electric dipole is placed at an angle of 30 degree to a non-uniform electric field the dipole will experience. So the concept is this one. Already we know if we place a dipole in a uniform field, the torque is acting on it except the angle theta equal to 0. The linear force acting on it becomes 0. But if you just considering a non-uniform field, if you place an electric dipole, here the intensity of electric field is say E1, it is E2. We know the E1 is greater than E2, and hence the force component here and here are different, and hence we can say the torque is not equal to 0, the linear force is not equal to 0. And hence, with respect to the choices, we can say the answer is C, a torque as well as a translational force for a non-uniform field. Non-uniform field. Number 18. An application of Gauss's theorem. If the electric flux entering and leaving a closed surface are 6 into 10 raised to 6 and 9 into 10 raised to 6 SI units respectively, then the charge inside the surface of permittive of the space epsilon 0 is. Before that, you should know one concept. And suppose here a uniform electric field is there. In that field, suppose we are placing a cylinder, and suppose we are assigning an area here. I am marked as A1, here as A2, and here as A3. We know the flux is nothing but equal to EA cos theta. Keep in mind the very important concept. The electric field with respect to this area vector makes an angle of 190 degree. Here 0 degree. Here 90 degree. And hence at this position we can say, as if I would take the value as EA1 cos 190 becomes minus. Here as if I to take the value equal to EA2 cos 0 1, it takes the plus value, and here the phi 3 take the value as a 0. And keep in mind the conventional concept. Here the lines of force are entering, so we can say the entering lines are taken as negative and the leaving lines are taken as plus, positive. Maybe the very important concept. Then the relevant informations are it is given the entering. So we can say that phi 1, that is nothing but minus 6 into 10 raised to 6, and phi 2 that are leaving, it is 9 into 10 raised to 6. We have to find the charge inside. So simply, the total flux is nothing but equal to the charge enclosed division by epsilon 0. So Q take the value as the phi total into epsilon 0. What is the phi total? We can say 9 into 10 raised to 6 plus minus 6 into 10 raised to 6. And you get the value as the 3 into 10 raised to 6 epsilon 0. And hence for question number 18, you can quote the answer as D. Number 19. a charge q microcoulomb is placed at the center of a cube of side 0.1 meter, then the electric flux diverging from each face of the cube is each face. Suppose if we draw a cube, the charge is placed at the center, and hence the total flux coming is nothing but equal to the charge enclosed by epsilon 0. But here we need to find from a face. A cube contains 6 faces, and hence the flux from a face is nothing but equal to q by 6 epsilon 0, and is given the charge here is q into 10 raised to minus is the division by 6 epsilon 0, and hence we can simply return the answer as C. Question number 20. A charge small q is placed at the corner of a cube of side A. The electric flux through the cube is, we can use this concept. Okay. See, in order to solve the problems like this one, we have to consider a symmetrical Gaussian surface always. So here the charge is placed at the corner of a square. So I am dividing this bigger one into so look at the figure. So if you just take one cube here, and we can say the charge is placed one of its corner here. In this big cube, that charge is at the center. But the symmetrical concept, we can say the total flux is equal to q by epsilon 0. That is fine. But here we want to find what is the contribution because of that small cube. But you know the bigger one is constructed because of 8 such cube together. And hence we can say the flux from a small cube is nothing but equal to q division by 8 epsilon 0. The similar aspect we can use it. So here that charge is at the corner of a sphere, cube. So we construct a Gaussian surface. The charge should be at the center. So a bigger cube we constructed, and hence it is built with 8 such cubes. The total flux is q by epsilon 0. Then from a small cube, so it is with 8 cube, and hence q by 8 epsilon 0. That is the answer we can say as D. Number 21. A charged ball B hangs from a silk thread which makes an angle theta with the large conducting sheet P. The surface charge density sigma of the sheet is proportional to. So here that plane sheet is there because of the repulsion here. You know the force is acting on it as mg, the force as QE, the tension T, and we can split them if it is theta, and then this become theta, they become T cos theta, and this become T sin theta. We solved it to be as tan theta equal to QE by mdg. But here we want to relate with the surface density. But we know the concept. For a plane sheet of charge, the contribution of electric field is sigma by 2 epsilon 0. So can be written as a Q into by mg into sigma division by 2 epsilon 0. And hence we can say the sigma is proportional to tan theta. So D is the answer. A simple concept. Number 22. A thin spherical shell of radius capital R has a charge Q spread uniformly over its surface. Which of the following graphs most closely represent the electric field produced by the shell in a range? So, we carefully studied the sections. Keep in mind, for the spherical shell, if we draw the electric field contribution, keep in mind, there is no charges inside, the electric field becomes 0. Then after that, it got the maximum value on its surface. Then it is proportional to 1 pi r square, and hence we can say as A as the more correct answer. But the case is entirely different for a uniformly charged sphere, and keep in mind there the curve become like this one. So this is the answer here. Number 23. The electric field at a distance 3r by 2 from the center of a charged conducting spherical shell of radius r is E. The electric field at a distance r by 2 from the center. So a sphere, at first it is given at a separation of 3r by 2, the electric field is E. Then what is the electric field at a separation r by 2? But is well inside. We already, the electric field inside becomes 0, and hence we can say A as the answer. And again the similar concept for 24. Question: a hollow insulated conducting sphere is given a positive charge of 10 microcoulomb. What will be the electric field at the center of the sphere? So whatever may be the case, we can say at the center, electric field at the center becomes 0, and hence we can say the answer is E. Number 25. The electric field strength in air is 3 into 10 raised to 6. The maximum charge that can be given to a spherical conductor of radius 3 meter is. On its surface we can say electric field, take the value equal to K into Q division by radius square. And hence Q can be find out as E into R square by K. The electric field given is 3 into 10 raised to 6 into the radius square as 9 by 9 into 10 raised to 9. 9 cancel. You get the value as 3 into 10 raised to minus 3 coulomb. So simple concept, we can say the answer as B. So students, please go through the every answers You can contact me if you have any doubt. Thank you.